The TCP SYN Scan relies on the three-way handshake process to determine which ports are open on a target host. The attacker sends a TCP SYN packet to a range of ports on the victim as if trying to establish a channel for normal communication on the ports. When a SYN scan is executed, the attacker will be looking for three states. Either the port is open, closed, or filtered. Here in the first picture in the top left corner, we can see how a normal TCP handshake works. First, a SYN packet will be sent. Then the server will reply with a SYN ACK, and finally the client will send an ACK packet. Now let's take a look at the open port scenario. If a service on the victim's machine is listening on a port that receives the SYN packet, it will reply to the attacker with a TCP SYN ACK packet. Then the attacker knows that the port is open and a service is listening on it. For the closed port scenario, if no service is listening on a scanned port, the attacker will not receive a SYN ACK packet. Depending on the configuration of the victim's operating system, the attacker could receive a reset packet in return, indicating that the port is closed. Finally, for the filtered port scenario, the attacker may receive no response at all. That could mean that the port is filtered by an intermediate device, such as a firewall or the host itself. On the other hand, it could just be that the response was lost in transit. A quick reminder about our lab. We have three hosts. The attacker is going to use Kali Linux at 10.0.0.222. The victim machine will be a Windows 7 host at 101. Finally, the penetration tester will use Kali Linux to intercept all the traffic and analyze any attacks on the network. Let's start. Imagine yourself that you are the attacker and using this host. First, let's check the network configuration of this host. We can see that the IP address is 10.0.0.222. Now this bad hacker is going to execute a port scan against our victim Windows 7 machine. And he is going to use Nmap to scan the Windows host at the IP address 101. From the attacker perspective, the scan is complete, but he doesn't know that a penetration tester is listening at this moment on the network. Now let's switch to the penetration tester machine and try to catch this intruder. I already opened Wireshark and loaded the saved captured file. One of the best ways to understand the scope of a scan of this nature is to view the conversations window. Up here in the menu, select the statistics item, then click on conversations. Next, select the IPv4 tab. Here, you should see only one IPv4 conversation between the attacker at the IP address 222 and the victim at the IP address 101. You will also see that there are 2039 TCP conversations between these two hosts. Basically, a new conversation for every port pairing involved in the communications. That's a lot. After understanding the different types of response a SYN scan can produce, which I showed you a while ago in the slides. The next logical thought is to find a fast method of identifying which ports are open or closed. The answer lies within the Conversations window. Once again, click on the TCP tab. In this window, you can sort the TCP conversations by packet number, with the highest values at the top, by clicking the packets column twice. 10 scanned ports include 3 packets in each of their conversations. Let's see the details of the first packet in the list. Click the Follow Stream button, then close this window. Minimize the Conversations window. Back to the main window in Wireshark, we can see the initial SYN packet sent from the attacker machine, then the corresponding SYN ACK packet from the victim's host, and the final reset packet sent from the attacker's host to end the conversation. Let's switch back to the Conversations window. We also have some other scenarios where only 2 packets were involved in the communication. Let's check the details again. Check the first initial SYN packet, and the second is the reset from the victim. This indicates that this port is closed. The remaining entries in the conversation window include only 1 packet, meaning that the victim host never responded to the initial SYN request.